Here's the Fourier transform circuit. Each one of these is an adder. It's kind of like an approximate multiplier done with an adder. There's 4 phases of 1.5 kilohertz there. 0, 45, 90, 135. Yeah, and there's 12 harmonics coming in the input, and they're all on, and I can switch 1.5 on and off. 1.5 kilohertz is on, and then the output's slowly climbing up to 200. If the output's off, and it doesn't matter the phase because I've got all 4 phases to collect it up at any phase, and it'll be 13 microamps when it's off. It wavers a little bit because this capacitor isn't quite big enough, but it's close enough. So I avoid a lot of mass by just putting every phase of the sine wave as operand B, instead of going for the follow-up hypotenuse compute, which is a lot more challenging. This is like a heap easier. And it's at 150, 160 microamps, then it goes up to about 200. If you shut it off, and then the sine wave shut off, but all the rest is still on, it'll slowly decline to 13 microamps. So it's all pretty easy. It's just a diode, capacitor, and resistors, and voltage entry. The only tricky thing is it only works with sine waves. So you got to generate those 4 sine waves there, but those ones are the signals, so they're just in the air. And this will get 1 harmonic out of 12 harmonics, and they're 100 hertz apart, and they're 1 kilohertz. The actual window size is declared by the size of the capacitor in the end. And that's the Fourier window. Is how much you sum it up over time. Yep, so that's the Fourier transform done in falstad. It's a pretty cool circuit. Probably my best one I've ever done. So why does it work? The frequency that's the same as these oscillators will always be the same reaction as it goes over time, but the other frequencies will change their mind about which AND gate they're going into. And so if they keep changing their mind, they add and take in the capacitor, and then they cancel out. But the frequency, the 1.5 kilohertz, the same as these, that doesn't cancel out. So all the harmonics cancel out except for one. If I've got a whole lot of, if I've got A plus B plus C plus D plus E plus F, all in a single number, if I times it by A, it's the same as getting A times A, B times A, C times A, plus D times A, plus E times A, plus F times A. And so it works in a sum. And that's how the Fourier transform works. That's quite freaking amazing. It's a bit like Pascal's law of fucking kick size. Anyway, that's the end of the lessons for today. And I've turned it off, and it's down to 65 microamps, but that'll continue to drop to 13 microamps, but it takes ages because of that capacitor. Yep, Fourier transform and falstad.